choosing a basis set. How we'll choose a basis set, right? First, we have to see the interactions and the type of reaction. What are the different interactions in a molecule, and the what kind of reaction you are working with. Okay, suppose there is a hydrogen bonding, or there is a mechanism involving there is a hydrogen bonding, or there is a hydrogen transfer, or the electron transfer, proton transfer, anything. In those cases, we'll be using polarization function on hydrogen also, and we'll be using polarization function. In those cases when polarization function on hydrogen is very important, like hydrogen bonding and this hydrogen transfer reaction, polarization function on hydrogen is also important apart from the polarization on the heavy element. Now you are having the diffuse function. When you are having the long range interaction, anions, cations, and weakly bound state, in those systems we use the diffuse function. Okay, that is mandatory to use. Now this double zeta and triple zeta, what are the use of these? So these generally increase the flexibility of the valence electron so that your accuracy will increase. Okay, at same time it will be very costly also. Heavy atoms and bond breaking and making mechanism, in those cases we generally use this double zeta and triple zeta basis. Okay, suppose you don't know what are the basis set for this specific element, because for each and every element all of these basis sets are not available. So to choose what basis sets are available for which element, there is a database. You can use this basis set exchange.org web portal, and there you can select the elements and it will give you the reported basis set. Okay, suppose you are working with organic molecule that will be having carbon, oxygen, and hydrogen. I'll give you one online demo here itself, right? We'll go to the portal here. Okay. Okay, suppose you are working with organic molecules that has hydrogen, carbon, nitrogen, oxygen. Okay, so when we have selected these elements, you can see these are the different. You can see the left hand side. You can see these are the different basis set which is available for those system. So you can use any of either of them. Suppose I choose this basis set. So with respect to this basis set, you can find out the corresponding, the citation or the reference for the specific paper. Okay, so this way it will be useful for you to get the reference and which basis set to choose for your molecule. Suppose you are working with some heavy or some transition elements. Suppose you are working with manganese, and then you are having fluorine, oxygen, nitrogen, carbon, hydrogen. These are the elements. In those cases, you will be having only these basis set which is available. Okay, in the split valence, these are the split valence basis set which is available, and then again you have different types of basis set which is available here. These are the Dunning basis set or correlation consistent basis set, and various types of basis set which is available here. Okay, similarly you can choose the different types of basis set for other elements. Suppose in case of you are having carbon, nitrogen, oxygen, and iodine, in those cases you can see only these are the split valence basis set which is available, and again you choose some other metal also here, so that split valence is gone. Means on those cases split valence is not available. That's why we use two different types of basis set to compute the properties. But I generally I don't favor like using two different types of basis set. Okay, thank you for watching this. If you have any doubt, you can put in the comment section.